And with that, I'd like to introduce Ashutosh Misra from ITN.
Good morning. Can you hear me? Yeah. So first, I would like to actually acknowledge NASA. ITN is, over the past 17 years, has beneficiary of a lot of NASA grant to develop a lot of clean and green technology. And actually, I'm pretty honored to be here at NASA, actually. So I would like to acknowledge that. I'm here to talk about a very unique technology which we are bringing next to the market. And this is called electrochromic film. And what I'm talking about it is a product, a clear film, something like this, what it look like. And by applying voltage or current, I'm able to change the tint. And I'm able to control the tint. And I take this film, and when I apply on these windows, I'm able to control the sun's light and heat which come inside this building. Just look at this room right now. What we have done, we have taken a natural environment and literally made it into an artificial black box, and then brought on these lights to now supplement that light which we actually could have easily used from outside. But unfortunately, we don't have a mechanism to use it today because the light is so digital. It's either too bright or it's too less. Our technology plays right into that. I can take that dumb window and make it into a very smart window. And I can change the profile of the tint based on that external lighting, what is available. And same time, I'm able to control the heat because sun produces a lot of heat, which ends up creating a lot of what we call solar heat gain inside the building. To offset that heat, we end up pushing a lot of air conditioning, which is a lot of cooling. So as you can see, I'm playing two very major components of energy inside the building. And that's where our technology can bring a lot of energy savings, substantial. We're talking substantial energy savings. What we are playing here is energy savings, human experience. By relating to an external environment, we're also creating an ambiance or ambient environment which is much more conducive, much more environmental friendly than what we are seeing right now. And we're also laying the foundation of next generation green buildings. We are bringing a component forward which will be a very strong component to create future green buildings. As I mentioned, electrochromic film or electrochromic windows have a potential to save 16% of US energy, which we are talking close to 16 cents for every dollar spent. And I'm only talking about US. If we put where the developing world is going today, especially India, China, Middle East, Southeast Asia, where the new construction is coming online, I think the potential could be much larger. Just to equate that energy savings in US, we're talking close to 700 million tons of coal. We're talking 16 plus trillion tons of cubic feet of gas and 2.3 plus billion barrels of oil. This is just, again, tied to US. Future demand. We can take the existing power generating capacity by use of energy efficiency. If we drop the load, that load gets freed up for future demand. So we really do not have to bring new power plants online in future. So we can create a true sustaining environment. 40% of US energy, in fact, our fellow presenter just mentioned 70%. I think the numbers are all over. But the numbers, I've gone with one of the report which came out of DOE. It talks about 40% of US energy consumption is in buildings. This includes both residential and commercial. Economic and political demand going forward is calling for green buildings or what we call also net zero energy buildings. Our technology, as I said, is that I can control that tint. I control that external environment. I can easily plug this into smart buildings, smart building control system, or even the future of smart grids. So this technology seamlessly integrates into the future of what we are talking today, of energy efficiency. This is just an envelope of what a commercial or a residential building look like. So as you see, what I'm doing is I'm taking a dumb window and making it into a smart window. And And by doing that, I'm able to control the heat and light which comes inside the building. And by doing that, I'm also able to create a human experience or an environment where you can relate to the outside world, which also directly relates to better productivity. In fact, there is a study out there, one of the studies out there our competition kind of talks a lot about, is how you can reduce the hospitalization costs. Patients recover much faster if they are in a room which has an external view, actually. This is a simple slide just to show how on the top we are playing with the electronics and how in the bottom the window goes from clear to a dark stage. So basically, we're moving the ions back and forth, and that's what is causing the tint. So as you can see, you can control it by a flip of a switch, or you can tie this to an active control system, or you can tie it to the building control, centralized building control system, and based on the time of the day, and how much light is coming in, what the ambient light is, what the external light is, and you can create a very intelligent building control system and have it work remotely, actually. Market opportunity. I mean, market opportunity for this technology has been there for a long, long time. But I think the biggest barrier, just like in any other technology, is cost. And electrochromics windows today are very, very expensive. I mean, we're talking $80 to $100 a square foot. And the second hindrance is there is no product out there which can address the existing windows or facades. ITN's technology, because we are on a flexible film, we can address both. By using our very unique roll-to-roll manufacturing, we can show a substantial cost reduction. We are almost talking a product range of $20 to $25 a square foot. In the same time, I can take an existing window or a facade and apply my film without making that glass obsolete. What's our vision? Our vision is a mass adoption of this technology. We think that as the mass adoption takes off, the potential cost coming down is drastic. In fact, I'm looking at bringing the cost down to as low as $10 a square foot. And at that time, pretty much I will be competing with your standard blind or any shading device, actually. So we think that as the cost comes down, this becomes a mass adoption both in residential and commercial application. We would like to contribute significantly to what I call the net zero energy building, a smart building. To make this building smarter, we have to make every component of the building smart. And since windows are one of the major components in any building structure, both residential and commercial, they need to become smart. I will also like to leverage our flexible form factor and open up adjacent market. And here we are talking about automobiles. I mean, if I give you a solution to you, instead of having a dark tinted glass on your automobile, if you can just flip a switch and change from clear to dark state at your will, you'll love it. Aerospace, next generation aircrafts, commercial aircrafts today are incorporating this kind of features already. Quick on competition. Our competition today have a technology which is very similar, but they're putting it on glass. So which limits them to a glass rigid substrate. And by doing that, they are also limiting them to the application they can go after. While we are being on a flexible form factor, I'm able to take this product and not only go after retrofit market, but I'm also able to, I'm also able to apply this in other form factors. I mean, I can go after curved building. I can go after wavy structures. As I mentioned before, cost is going to be the key to enable the mass adoption of this technology. And roll-to-roll manufacturing on a plastic substrate, if you model that, is one of the cheapest manufacturing platform. I don't have to go process 20 feet by 10 feet wide glass through a manufacturing line. And just think about the storage, the handling, the transportation. Right? It's a nightmare to handle glass. But if you break one glass, there goes all your product. my manufacturing is going to be on a roll-to-roll. So I can take a meter-wide roll on a diameter of 8 or 10 inches, and I can process 1,000 square meters of that. So that's where the cost advantage is going to come from. An application beyond flat glass also creates an opportunity for premium. New markets. Beyond buildings, as I mentioned, automobile, aerospace. In fact, we think the future of display industry, I mean, this is something maybe 5 to 10 years, but we could really change. Because this technology really requires very, very low power. I mean, we are talking microwatts or milliwatts. I can create a two-tone display with a very, very little power. This is a long roadmap to develop this technology. In fact, I'd like to also acknowledge another council member here from EPRI who have funded this technology since 2007, 2008. So as you can see, this was one of the derivative technology which came out from our byproduct of thin film solid-state lithium battery. And that technology development started at ITN in 1998. And between 1998 and 2009, we spent close to $18 million in various internal funding or research grants to develop this technology as well as our thin film battery technology. So we had a pretty robust technology platform before we went to ARPA-E, when ARPA-E came up with this solicitation, when ARPA-E was formed in 2008 after the new administration came online. And we were very fortunate to win a $6 million grant from ARPA-E to take this technology from lab scale to commercial scale prototype. We also partnered with some of the leading organizations in the industry to bring this technology forward. EPRI I just mentioned about. Southern California Edison is also part of our program, and one of the things they are bringing to the market is market validation of this technology, and as well as how this technology can play an important role in a market like Southern California, which is one of the largest consumer of electricity. Second, we got a lot of building and structures which have a lot of glass. And the third is that this technology is a complementary technology to peak load. So California, as everybody's aware, we have a tier tariff structure where the tariff structure keeps going up as you consume more power or time of the day. This is a perfect technology to complement that peak tariff structure. We also partner with an industrial partner as well as institutional partner here, Colorado School of Mines. As I mentioned before, on the left-hand side, what you see took us almost 12 years to get there. A lab-scale prototype, but 4 to 5 inch or 4.5 inch by 5 inch. And what we're trying to do in the last 2 years is to transition that technology into a 0.5 meter wide roll format. On completion of this program, we think or we feel that technology risk is pretty much retired. Going forward is going to be engineering. And that's where we want to get into what we call initial manufacturing and create the market demand for our product. ITN also brings to the table not only the innovation in technology and product, but we also bringing forward our innovation in manufacturing. And this innovation is what we call roll-to-roll manufacturing, which has been validated by 2 of our other spin-offs in solar field. So we are very confident the manufacturing technique which we are bringing forward is well proven to apply to this technology. How do we want to go forward? Just like in the past, we have created successful spin-offs. We would like to create a new spin-off to take this technology to the market. We have laid out a 5-year vision, which is in 3 phases. Phase 1, phase 2, and phase 3. Phase 1 is primarily pilot production, primarily for validation of technology, continuous improvement in technology and efficiency, which is manufacturing efficiency, cost reduction, market seeding, product development, testing and evaluation. In fact, we have a program as part of the ARPA-E program. EPRI, as well as Southern California Edison, is going to be testing and evaluating our product, actually. And we'll continue to do that. So phase 1, this is where we'd like to see. And based on the success of phase 1, based on what the market pull we create, we will now migrate to phase 2, which is our real production. And in phase 2, we think that with our cost model, we will be EBITDA positive in 3 years. And phase 3 is, to me, is pretty much you go anywhere where the market demand is, any part of the world. What am I looking for launch? As I mentioned before, ITN as a company has been very fortunate to at least have a fellow member here who has already supported this technology. What we are looking is to go take this technology and bring it to the market. I think we have done a substantial amount of work from the innovation side, the research side, the development side. I think bringing something like this to the market will require a lot of help. And the help could go into today into a product adoption. I'm looking for window or facade manufacturer to work with them and how I can incorporate my product into their offering. I'm looking for how do I put together a financing round for the phase 1 expansion. I'm looking to partner with people who can have ideas how to scale up this technology and retire some of the manufacturing engineering risks to bring the cost down further, packaging, deployment. And I also like to brainstorm. I think the technology is so unique that I personally think I only talked about 4 applications. I think there could be probably 10 more. So I would like to brainstorm with a group of people here and see what they think based on their experience in real life. Where else can I use this technology? Education, marketing, public relations, I think this is very important. Anytime you bring a new technology to the market, having others talk on your behalf makes a huge impact. I mean, I can keep talking about my technology, but if I can convince somebody like you to go talk on my behalf, that's going to take me probably 10 times more further than I can go on my own. So that's another help I'm looking for. Word of mouth, spread and educate the potential user of this technology that what is out there and how they can incorporate that. And with that, I will end, and I'll go to Q&A.
Thank you so much, Ashu. So let's go straight to questions. And if you could please identify yourself before you ask your question. And I can't see your names from here. Yes, please.
Hi, I'm Peter. The film goes on the inside or the outside of the glass? Inside. Presumably, this has to be connected up to something.
Yes, it does.
As a power system and a set of sensors.
So you can do several things. One is if we have a product which we conceive, which could be standalone product of a window. In fact, I can combine 3 of my technologies and create a smart window where I can take my electrochromic film, which goes on the window, which could go inside or one of the glass surface inside or even in the middle. I can put a strip of a thin film solar outside and take my thin film battery technology, combine all the 3. And what you have, because my power consumption, my power requirement is very, very small. So I can use the external sun, generate the power from the solar cell, charge the battery, and have a sensor. And based on the programming, I can change. So I can create an individual component. In the building system, in the retrofit, it is a little challenging. But if you see, most of the frames around the glass is hollow. So it's very easy to drill a hole and move the wires around. So that will require, I think this is where I think we need to work with the curtain wall manufacturer, the facades or awning manufacturer, and see how we can marry this together.
Alex.
So, it almost seems to me that you should be thinking about connecting with the previous presenters, PowerZoa, because I think, have you thought about connecting this to some sort of system that could tie the degree of transparency of the windows to, light conditions outside, to annual variations, to weather reports, to individual preferences. So someone could come in and say, I'm going to be working today, I need minimal light for my computer screens, and they can literally hit a button to adjust those systems to do so.
And those are the opportunities we are looking to work with people. I mean, you're talking about architects. You're talking about even the future building, the green building, not architects, but the people who conceive the future green buildings.
But have you actually thought about developing a parallel system that could work with not just the thin films, but then do the programming in the system
No, I think our core competency is in thin film manufacturing. I think that's where we want to concentrate. I think any value-added product, I think I see this as a B2B model. I don't want to do B2C. I think I want to focus on my core competency, which is scaling of the manufacturing. Yes.
So one of the major consequences of global warming is
Mikhail, could you come closer?
closer to the mic.
You don't get an invitation like that every day.
Now you'll get to know me. One of the consequences of global warming is water scarcity. As a result, more and more crop production and plant production is moving into greenhouses. Will we, with
Perfect application.
Yeah, will we, with your product, be able to document increased yield? As an example.
This is, and I want to be honest here, this is something, it just came out of a brainstorming session I had with one of my NREL colleagues just about 3 weeks ago. That in a greenhouse, what happens is that you end up, again, environment and control is one of the biggest challenge there. So if it's too sunny, you have to push energy in to cool it down. So if I can manipulate that environment, just like I talked about in buildings, greenhouse will be another perfect application.
And Daniel, please.
Just a really quick question. Hopefully it's general enough. Your team, just tell us a little bit about the team. It sounded like very technical product development project right now. Commercial side, hiring plans, building out.
So I'll start with me, actually. So I just came off my previous spin-off, which we did called Ascent Solar. And we spun that company off in 2005, and I was one of the 3 management team which went from ITN to start that company. And I was head of operations there. And I was responsible for taking that technology from the lab into now large-scale production. We have a 30-megawatt plant in production, which we spent close to $125 million. I was also part of recruiting like CFOs, head of manufacturing, sales and marketing, business development. What we have at ITN, we have a very successful business model. We have a very strong technical and what I call a commercialization team. In fact, people ask me, what's your core strength? So I say, if in one word, if one sentence I have to describe, I call it disruptive technology commercialization. I mean, it's very easy to go find good people in the support structure. But if you don't understand how to take a technology from lab into manufacturing, because this is where I think the challenges are, I think there we are very well complemented. We also have a fantastic network because we've been around for almost 17 years. We have created 4 successful spin-off companies, and if you look at the investment which have gone in, probably more than $500 million. So we also have followers. So when they see a new venture, they start calling us, actually. So we also attract inward talent, actually.
David, please.
The technology sounds pretty strong. I'm
Thanks
familiar
to you.
with I'm familiar with lithium ions. I started out with that at Oak Ridge a long time ago. But to have an interactive system, which is what you're implying, you're going to have a series of sensors and a series of control systems.
Yes.
Not just and the algorithms. The algorithms are easy. You can do that, but the controls aren't.
Yeah, I mean, the good thing is that there's a lot of work going on. Again, I'm going to rely on external partners, and I'm going to claim that I'm the expert on that. But I think a lot of work is already going on in the so-called the HVAC control systems, which is now been tied to lighting, heating, cooling. Companies like Johnson Controls and Honeywells of the world, they're doing a lot of work. I think if I can bring in to them, incorporate what I call a light sensor, and based on the habit or the program, I think we can work together with them to design an integrated control system. But that's an evolution.
Are you talking about a solar power generation? Because you don't need much power.
No,
what you're doing.
not for us. I'm talking more about how to, just like you said, how to bring all the 3 or 4 pieces together in sync.
Can you put it all in your film, is my question.
Theoretically, yes, you can. I mean, if you look at the future is flexible electronics. Actually, if you think about it. In fact, we were one of the first companies that conceived future flexible displays like 15 years ago. But if you look going forward, I mean, electronics is going to move to flexible. And I can easily create at the bottom of my, a flexible form factor structure, which can incorporate exactly what you're talking about and make a monolithic structure.
Just something to think about.
No,
Diana, please.
So I have two things. One is how linear is the scale up from your 0.5 meter to your 2 meter? And the second question is, does this technology allow you to disaggregate the filtering of heat versus light, or do you have to?
It
Okay.
does both. You know,
It does both simultaneously, or can you let light in without heat?
The way is that it's kind of pretty much both go in the modulated together.
Okay, so you can't disaggregate them?
No, you cannot,
Okay.
actually. Kind of, you know. Scale up, and this is exactly where I came. To me, the challenge going forward is engineering, which is what comes in scale up. So when you go from 4 by 4 inch to 0.5 meter to 1 meter, 1 meter, 2 meter. Personally, we have done similar scale up in solar technology. We went from a device to 12 to 14 inch wide roll, and now we're trying to scale that technology up to 1 meter. So if you scan, I don't want to be pounding my chest, but if you scan the universe when it comes to roll-to-roll manufacturing and trying to have an expertise in multi-layer manufacturing device structure, you'll actually pretty much come back to ITN and see that we were one of the pioneers, what we call roll-to-roll manufacturing, and we have invented a manufacturing system which is called IPC, Intelligent Process Control. So one way you control the dynamics of the manufacturing is that we have a real-time monitoring built into our manufacturing chambers. So that's what, but it's not a small challenge, and that's why I have a 5-year roadmap. I don't have a 5-month roadmap.
Carrie, please.
So there's a lot of potential applications, but who do you see as your first 3 ideal large customers?
I'll say window manufacturers.
Okay.
I will also, one of the lessons I've learned from the previous spin-off, that always try to find to de-risk the technology and find somebody like a sugar daddy who can afford to pay you.
Of course.
And we think automobile and aerospace could be the one.
Call it angel investors,
I think aerospace, just to give you, in aerospace today, both Boeing's Dreamliner and Airbus 380 both have electrochromic, but it's glass-based. It's a bulky solution, and I can easily convince them to switch to mine with a lot of cost saving.
Okay.
Automobile, just to give you an example, I can take your existing sunroof, which is actually a two glass sandwich, which is held by a plastic film in between, actually. Every car has that.
Have you been having conversations with these?
Yes.
Okay.
Actually, because of our heritage with solar, I already did a lot of work with some of the. In fact, we were one of the. I mean, Jigar will talk. We were one of the first people in solar industry who talks about putting solar on top of buses and cars, when everybody was talking, and now it's becoming a reality actually. So we have a lot of inroads. I personally have a lot of inroads with the. But any new leads is welcome.
And last question, please.
Hi, Ashu. This is Nagesh Rao. Just wanted to know, what does your intellectual property strategy look like for the technology? Have you filed for U.S. patents or international patents and whatnot?
Personally, as a company, we are not a big fan of patents. You may call it whatever, because our DNA comes from aerospace, so we tend to hold a lot of things close to our chest. So a lot of our technology is process related, and that's where we control product patents. So I'm very, very open to go out and file product patents. But on process, we really don't talk. So it's all pretty much held like a
trade secret sauce.
Just like Coca-Cola's secret sauce, you know.
How do you counteract the potential for reverse engineering?
I mean, I always tell people, if they can, let them do it. This is not something which you can go reverse engineer over next 1 or 2 years with $1 or $2 million. I mean, anything can be reverse engineered, but it'll require a lot of effort, a lot of time, and a lot of money.
Thank you so much for your questions. Thank you, Ashu.
Thank you.